Okay, we have officially started our session for today. Siguro naka-on yung camera ko. Yung iba kasi daw parang pag nakikita yung mukha ko, mas engaged daw sila doon sa video. Tinry ko last week yung 1:30 ko nakasindi yung mic. Ay, naka-on yung cam, pero yung sa hapon, naka-off. Kasi walang nagre-react sa akin. Buti pa dito may nagpo-on sa akin. Wait lang, naka-record pala yun. Okay. Kung mo na ako masyadong lalapit, makahalata yung eyebags. Pero yung screen ko kasi nandun. So, baka maano lang na slide. So, ano ako. Anyway, moving on. So for week 2, our ating main topic is on Big O and algorithm complexity. So let's just look at yung ating study guide. So meron tayong objective over here. So yun, this week, we will study algorithm complexity. In particular, yung tinatawag natin Big O notation, which is a measure of yung tinatawag natin na runtime complexity. So you will be how you should know by the end of the week how to calculate big O function big O for functions in general. So meron din tayong mga ilang algorithms na introduce na commonly used, especially with regards to sorting, and kukunin yung kanilang mga big O notation. So at the end of the week, reasonable mastery, hindi naman yung kahit isang tingin mo sa algorithm, wala mo na yung complexity nga, hindi naman yun yung expectation. Pero pag binigyan ka ng algorithm, bigyan ka ng mga 30 minutes, makukuha mo yung algo complexity, pinakita algorithm sa'yo. So actually, yung major part nito is yung big O na handout. Actually, yung sorting algorithms, dito na masyadong i-focus kasi medyo mas makuha niya yung visually. Or actually, tingnan natin later yung sa visual algo. And ayan, dito sa week 2 na Big O handout, ayan, so merong medyo mahabang introduction. Pero basically, ang sinasabi lang nito, di ba, as engineers, gusto natin efficient yung ating mga ginagawa. So, for example, di ba, EEE, if meron kang circuit, marami yung power na ginagamit. Kung light bulb, if yung half ng energy na ginagamit ng light bulb is para uminit siya, kalahati lang yung nagiging ilaw, then it's not a good light bulb. And the same is true for our algorithms. Pag yung ating algorithm medyo mabagal or madaming resources na ginagamit, medyo gusto natin siyang i-improve and i-optimize. So yung ating measure nung kanyang paggamit ng resources is nilalagay natin o tinatawag natin na complexity. Kasi, for example, if gusto lang natin tignan yung running time ng isang program, iba-iba kasi siya per computer na gamitin mo. If meron kang computer na mas malakas yung processor, mas mabilis siya matatapos. So kung meron kang magandang PC pero pangit na program, and meron kang magandang program pero pangit yung PC, baka magkasing bilis lang sila. So ang tinitignan natin is not the actual runtime but what we call na complexity or gaano siya kabilis bumagal or gaano siya kabilis gaano kalaki yung paglaki ng time consumption niya with respect doon sa input. So, ayun, for example, dito, itong ating unang function over here, f1 of n, print n. So, isa lang yung ginagawa niya. So, si n, kahit gawin ko siyang 1 million, yung pag-print natin, ang pag-print ng 1 million, medyo hindi siya masyadong nagkakalayo. when we compare it to, let's say, print 1,000. Excuse me. Sorry, medyo busog pa. Well, kung titingnan mo under the hood, baka mas matagal ng konti yung print 1 million kasi mas madami siyang characters, pero essentially maliit lang yung difference niya. Pero pagdating dito sa F2, 10 times niyang ipiprint yung input. So, ayun. Medyo pareho pa rin. Pag nag-print 1 ako, 10 times siya lilitaw. Pag nag-print 10 ako, 10 times lilitaw yung 10. So, parang same lang yung paglaki. Hindi siya lalaki masyado. But yung malaking difference dito sa F3, print I, for I in range n, print n. So, you print n times. So, kung 10 to, magpiprint ka 10 times. Pag 1 million to, magpiprint ka ng 1 million times. So, doon na nagkakaroon ng malaking difference from F1 to F3. So, si F1, if we compare yung input na 1 and 10, siguro yung difference in runtime mga dumoble lang kasi dalawang characters na yung ipiprint natin. Pero pag dito naman sa baba, difference from 1 from n equals 1, which is 1 time lang siya magpiprint, compared that to n equals 10, 10 times siya magpiprint, so times 10 yung nakukuha nating runtime. So, yung ito naging times 10, ito naging times 2. So, yung complexity natin is related to that number. So, moving on over here, mas maraming examples. Ito, nested na for loop. So, kung 10 times magra-run yung loop na to and meron loop sa loob niya na magra-run 10 times. So, 10 times 10, naka-square or n squared times yung magra-run. So, comparing this one to the first one, ito times n yung increase, ito times n squared yung increase. Now, dito naman sa susunod, similarly, ganun din. Meron tayong isang loop na n times, meron tayong isang loop na n squared times. So, ayun, may isang property lang tayong tinitingnan later on kasi ang assumption natin n is very large. So, mas malaking lumaki si n squared kaysa kay n, kumbaga. So, yun lang actually tinitingnan natin. So, ayun. So, medyo complicated ng slide kasi nagbibilang tayo. And kung wari madami na tayong for loops, kung mahaba yung expression natin dito, n squared plus n, ito n squared, ito n, ito constant lang, almost. And pagdating natin sa mas complex na algorithms, paano if maging n squared, paano n cubed plus 3n minus 2n squared. So, medyo mahirap siyang i-evaluate talaga kasi yung time complexity. Kung yung ang gusto lang naman natin tignan is yung gaano siya kalaki lumaki, ang pinaka may effect lang doon yung largest na term. So, kung medyo kailangan niyo pa ng mas in-depth na explanation doon, I guess kailangan yung puntahan yung specific na videos kasi medyo generic yung pagkaka-explain ko ngayon. So, instead of just using yung expression ng time, gumagamit tayo ng tinatawag na big O notation, wherein hindi natin kukunin yung exact na runtime, pero kinukuha lang natin yung parang limit or yung shape ng runtime. So, kumbaga dito, ito si x squared at saka si x squared plus x, pareho sila ng shape. So, pareho sila ng rate ng paglaki. So, we consider this as same yung kanila tinatawag na big O. So, big O is essentially yung ating limit. So, ito, kung wari, ito yung naka-zoom in tayo. So 0 to 6 yung x-axis. Pero pag ginawa natin 0 to 400, si x squared plus x at saka si x squared, halos same line na sila. So for big numbers, well, may big siya sa umpisa pero hindi naman necessary dahil big numbers. So instead of kailangan pa natin tandaan yung x squared plus x, ang tatandaan lang natin si x squared. So ganun lang siya. So ito yung formal definition niya. Medyo mathematical. So basically, yung big O, g of n, is equal to f of n such that there exists a constant c and a constant n naught greater than 0 such that f of n is in between 0 and g of n multiplied to a constant for all n. So basically, yung sinasabi niya si f of n, nasa gitna siya ni 0 at ni g of n multiplied to a constant for all possible inputs kay f of n. So, ayun, kuwari dito, so si g of n, siya yung big O natin. Si f of n, siya yung original na function. So, kung yung original na function natin is x squared plus x, isa niyang g of n, si x squared. Kasi si x squared, pwede ko siyang i-multiply by 2 and lagi siyang magiging greater than yung ating x squared. So, maraming pwedeng actually maging g of n yung atin, wala si x squared, pwede kong gawing x cubed yung g of n niya, pero hindi siya yung parang limit dun sa g of n. So, mas kinukuha natin yung pinaka lower, pinakamaliit na expression na kaya natin isaksak tayo g of n. So, ayun, few more examples lang to. So ito, yung malaking difference, pagka si f of n natin is equal to x, hindi siya yung g of n niya. I mean, si si g of n equals x, hindi siya pwedeng maging big O ni x squared. Kasi kahit anong ilaki natin kay y of x, hindi siya magiging overall mas malaki kay x squared. So ano yung rules na sinusundan natin when we consider big O? So yung ating normal operations like assignment, comparison, and addition have the complexity of O of 1. So si g of n natin is 1, constant lang. So yung addition operation natin, kahit gaano kalaki yung ina-add natin, pareho yung running time niya or pareho yung complexity. Hindi siya ganun ka laki gumala. And almost negligible yung difference. And then, ayun. Basically, anything that has a constant number of steps will have a complexity of O of 1. So, O of 1, siya yung pinakamabilis natin na complexity. Hindi ginamit. Meron tayong mga comparisons ng mga growth rate ng functions. I'm not sure kung makikita natin. Kasi merong usual set ng big O na ginagamit. Ito. Yan. So, O of 1, constant, halos hindi lumalaki. And O of 1, constant, hindi masyadong lumalaki. Si log of n, medyo maliit lang din. Si linear, nandito. Nandun pa siya sa medyo good performance. Si n log n, dito. Medyo fair. Si n squared, yun, medyo masama na. Although, minsan hindi natin may iwasan na n squared. Tapos 2 to the n at saka n factorial. So, yung ating best complexities na doon sa constant, log of n, O of n, linear. Ito yung log linear, siya yung parang average. Pag umabot na tayo sa mga n squared, kasama pa dyan n cubed, n to the fourth, n to the etc. Ngayon, medyo mabilis lumaki yung mga yun. And then, isa sa mga pinakamabilis lumaki, si n factorial. Usually, pag meron kang O of n factorial na function, ayun, better find other ways to do it. And then, ayun, going back, ayun, so our loops have a complexity of O of n, where n is the number of times the loops iterate. And then more specifically, n times f of n. So, makita natin ito later with more examples. So, kung ano yung time complexity dun sa loob ng loop, yung multiply natin sa number of iterations. And then yung pag meron tayong mga nested na loop, mag-multiply lang sila. So, and then if we have sequential algorithms, so meron tayong mga sunod-sunod na operations, ang kailangan lang natin i-consider yung pinaka-complex sa kanila. So, kung meron tayong linear, kuwari dito kanina, meron tayong linear na for loop, meron tayong quadratic na for loop na n squared. So, ayun, ang kagandahan ng ating big O notation, kahit hindi natin pansinin yung linear na term, yung quadratic na lang na term. So, kahit hindi natin pansinin si O of n, si O of n squared na. And siya na automatically yung magiging overall complexity ng ating function. Then, yun pa. Next pa. Control statements natin. If or else if have the total runtime for checking the condition plus yung runtime ng ating pinaka-complex na body of code. So, ang big O complexity din kasi yung tinatawag na worst case na time complexity. Kaya siya upper limit. So, upper limit siya. Hindi lalaki si f of n sa kanya when multiplied to a constant. So, it's the worst case na time complexity. So, if meron tayong conditional na statements, yung worst case or alin yung pinakamabagal doon sa mga if-else statements, yun yung susundan natin. Then, ayun pala, yung commonly used na big O functions, so constant O of 1, linear O of n to the anything, n squared, n cubed, n to the fourth, log n, n log n. Tapos meron pa tayong 2 to the n, 4 to the n, 3 to the n. So, mas malaki pa yun. And so, meron pang mga examples dito. Kumari ito, yung first one over here is just x equals n plus 1. So, assignment and addition. So, that's just a constant operation. So, kaya siya e of 1 over here. So, lagyan na natin na annotations. So, t of 1. So, t of 1 siya. So, belong siya kay o of 1. Dito naman, ang operation natin is now multiply n times. So, dahil itong nasa loob, yung function sa loob is o of 1. And nag-ulit tayo ng o of 1 na operation n times. So, n times o of 1. So, paumanhin po sa aking sulat. So, n times o of 1, yung ating overall na time complexity is o of n. So, medyo pumapasok lang si o of n sa loob din. Then, ayun. Dito naman sa huli, going from, well, meron kasing dalawang sinusundan usually. May mga going from the outermost to the innermost. So, magsa-start sila dito, n times kung ano man yung nasa loob. So, star, kumari, kasi di mo pa alam. Tapos, kukunin mo naman yung nasa loob. Tapos, lalabas ko ulit. Ang mas prefer ko is, magsisimula ako sa innermost na expression. So, yung pinakamaraming indents. So, ito ay constant. So, actually, dalawang operation to, di ba? So, assignment and addition. So, ito ay O of 1 plus O of 1. And if meron mo kayo nakikitang joke sa internet, pag sa computer science people, O of 1 plus O of 1 is O of 1. So, hindi siya O of 2. Kasi hindi marunong mag-add yung concept. Pero gets naman kung bakit hindi siya O of 2. Meron bang mga nalilito kung bakit O of 1? O of 1 plus O of 1 equals O of 1. Kasi kung babalikan natin yung original na definition, yung ating G of n, pwede natin multiply by a constant C pag i-compare natin siya kay f of n. So, since kahit O of 2 siya dapat, si O of 2, equivalent lang din siya kay O of 1 na si C ay equals of 2. So, para maging uniform, parati O of 1 na lang yung gagamitin. Tsaka, yun din, para siyang C. Hindi ko nasakto. So, yeah, pwede na. Okay, going back. So, O of 1, yung nasa loob, and multiply natin siya by M times O of 1. So, ito, O of M times O of 1, bakit hindi siya magiging 1 na lang ulit? Kasi si M, hindi naman siya constant. So, kailangan yung maging result nito is O of M. Now, kung wala ito, palitan to, gawin kong 10. So, kung maging 10 times O of 1, ang sagot natin doon is O of 1 pa rin. Kasi constant si 10. Pero kung M equals 10, O of M pa rin kasi hindi na siya constant. Variable na kasi siya pagdating doon. Pero balik tayo sa So, ito naman sa labas. So, yung nasa loob ng for loop is O of M. And ilang times natin siya ulitin? N times. So, N times O of M. So, O of N M. So, yung big O natin, notation, can comprise of multiple variables. So, in this case, N and M. Pero for example, nakakuha ka ng expression, nakita mo na si N equal pala siya kay M squared, pwede mo pa itong simplify na O of M. Pero of course, kailangan na natin ng additional information about N and M. So hindi na enough yung ito lang yung nakikita natin. So ayun. Clear annotations. Moving on. Ito pa, more examples. So ito, tatlo yung inputs. So ayun, usually start with yung innermost, this one. So this is O of 1. And then CM input siya. So M times O of 1, which is O of M. And then, ayun lang ito pala. If K greater than I, we break. Pero si K is an input. So, ayun. Kahit na may chance na mag-break tayo, so ang ibig sabihin ng break is stop na. Tigil na natin to. So kahit nasa loob siya ng for loop, titigil siya. So effectively, pag si K ay greater than I, magsa-stop na yung loop, hindi na siya mag-run. So for example, if si K equal siya kay, magsa-start siya kay 0. So kung wala si K equal kay 10, regardless, kung wala si N equals 1, so equals 2. So mag-start to at 1, kahit 100, 20. So kahit 100 to, pag nagsimula tayo dito, 0, greater, 10 greater than 0, so magbe-break na. So titigil na siya. So essentially, yung running time natin doon is constant lang kasi hindi naman siya nag-iterate. Kaso, recall na yung time complexity, kino-consider natin yung worst case. So ang worst case natin is K maging -1, for example. So if -1 to, never siya magiging greater than 0. So parang non-existent na to. Although, kailangan pa rin natin i-perform yung check na to. So, that's a O of 1 na runtime, yung pag-check ng condition. Pero kahit hindi tayo pumapasok sa loob niya, kailangan pa rin natin siyang gawin. So, yung total na running time naman ng loop na to is yung dito sa loob plus yung since magkasunod sila, di ba? So, since big O, kailangan lang natin consider yung biggest, pero we can always show na it's O of 1 plus O of M all multiplied by N. So that would be equal to O of N plus O of N M. Now, since si O of NM, lagi naman siya may mas malaki ng O of N. Si M, hindi naman siya, we assume that M is always greater than 1. So kahit tanggalin na natin to, hindi natin siya kailangan consider. Yung big O ni D, big O ni D of N M K is equal to big O N. So, wait. Yeah. Okay pa tayo dyan. So, dami pa to. Marami pa akong inventory. Meron na. Meron pa pala. And then this one. Okay, so meron tayong while loop, meron tayong for loop. So, start tayo dito sa pinakaloob. We have an addition operation. That's O of 1. And that runs for M times. So, big O of M. So, hindi ko na iniwalay yung multiplication. Diretso ko na. Sanay na kayo. Sanay na dapat kayo. Alam ko na yun. And ito naman, while loop natin, tingnan natin. Ang condition nga is I less than K, I less than N. So that's just a constant operation. So I guess yung laman ng loop is O of M plus O of 1, yung pag-check. So O of M yung dahil dito, O of 1 yung dahil dito. So ang kulang na lang natin is yung number of iterations. So, ilan yung number of iterations natin? It depends. So, either K or N, whichever is yung mas malaki. So, pwede natin gawin, dalawa yung cases natin. If may siyang O of Km, if K greater than N, then O of Nm if K less than N. Lagay lang tayo ng equal para lang covered lahat ng bases. So parang magiging piecewise siya. So hindi ko na sinama to kasi maliit lang naman siya. Another way of putting it is pwede rin natin siyang gawin. O Km plus Nm. In this way, whichever yung mas malaki, magdo-dominate, magka-cancel out yung other term. So ako, personally, this is allowed and this is okay din. So, ayun. Ang alam ko naman kasi ako yung mag-check ng mga so others will only consider this one, or for example dito hindi niya kinonsider si K, or parang si N na yung kinonsider niya, so parang special case lang si K, so NM pa rin sila pareho. So ayun. Pero ako actually ito yung mas prefer ko kasi mas kompleto siya and isang line na yung kailangan. And if mas malaki pala si K, pwede magdo-dominate to, maka-cancel out din naman to eventually pag meron ka ng value for K. So, Ang big O natin, yung nasa loob niya is an addition, pero isa lang yung while loop natin. So, hindi siya, parang wala tayong masasabing direct na relationship between those. So, talagang kailangan natin daanan yung ating uh, analysis ng algorithm. Kaya nga siya tinawag na algorithm analysis kasi kailangan mo siyang i-analyze. So, ayan. So, di porket dalawang while loop yan, k times m or n times k. So, kailangan natin tignan yung laman ng ating function. And then, ano ba yun? Yeah, and then ito naman yung dalawa yung ating O of 1 dito sa loob. So ito yung medyo mas explicit. So meron tayong O of 1, O of 1. If we add them together, O of 1 plus O of 1 is O of 1. And then we repeat the loop for n times. So n times O of 1, O of. So madali lang naman. So ito, additional cases, yun nga. So hindi na siya nag-apply sa constants. Pag O of 1 plus O of 1, O of 1, nag-apply din siya sa, actually lahat ng ibang case, ito yung linear lang. So basically, yung sinasabi lang nito, if constant times a linear, it's still O of n. So basically, O of n plus O of n is equal to O of n. So hindi siya O of 2n. Technically, tama ka pag sinabi mo O of 2n. Pero ang sinasabi natin, ang hinahanap natin sagot is O of n. Kasi gusto natin as simple as possible yung nasa loob ng ating big O. And ito rin kasi yung pinakita kong table or yung table kanina. Ito yung mga usual na, I mean parang convention. Conventionally, ito yung mga big O na hinahanap natin na form. So usually yung form lang yung hinahanap, or sometimes we just call it linear in this na O of n, or log linear log, quadratic, cubic, etc. Hindi ko na alam yung tawag sa to the fourth. But essentially yun, usually you can also say yung big O in a descriptive way, or can say it na, yeah, O of n. And then, similarly, pwede pa natin extend big O of n squared, m squared, plus big O ng 3m squared. Actually, ito is equivalent na rin, equivalent siya sa m squared. And then pag in-add natin is still O of m squared. So yung medyo hindi lang siguro malinaw, kumari big O ng 2 to the n plus big O ng 4 to the n. Actually, yung ang alam ko is magiging, since mas malaking term si 4 to the n, magiging big O of 4 to the n siya. So, pwede ba itong maging big O ng 2 times 2 to the n? Tapos matatanggal yung 2. Well, personally, wag mo natanggalin. Okay na ako dito sa 4 to the n. Hindi naman siya kailangan mo yung 2. Malaki din naman kasi yung difference pag base 2 at saka base 4. So, ayun lang. Next. Okay, ito yung multiple variables. Usually, pagka magkapareho, kahit isa lang yung inilalagay, understood na linear siya. So actually ito is pwede mong gawing big O of x plus b. Although sometimes pwedeng ma-reduce siya to yun nga, O of n lang kasi pareho lang naman sila linear. Another case is kung x squared to. So big O ng x squared plus b. So ito is magiging most likely O of x squared. Since si b is hindi siya naka-square, mas magbagal siyang lumaki. Although yun, nagmamatter pa rin yung ating consideration kay x tsaka kay b. Kasi kung si b, ang alam natin na value niya is from 0 to 10 lang, or baliktad pala, 0 to 1 top cube. So kung 0 to 10 cube si b, tapos si x ay from 0 to 10 lang, actually kahit hindi na nagmamatter si x, mas magmamatter si b in the long run kasi mas malaki siya. So ayun, usually yung ating big O, kailangan natin dagdagan ng konting context. So ayun, well, ang sa akin is pag walang context, wag na natin siyang i-simplify further. Pero ayun, if magbabasa kayo ng references online, that is also allowed. So since hindi naman talaga tayo, this is more, yung formalities naman ito is more for comp-sci majors, yung mga nag-aaral talaga ng algorithms. Although, we can go that path din naman kahit nasa triple ka. Pero yun, so it's for a more in-depth discussion yung pag-formalize. Then ito, nabanggit ko na rin kanina, dominating terms. So kung alin yung pinakamalaki, an squared, bn plus c, kahit hindi natin pansinin si b and c, we already know na an squared yung magiging big O natin. Then, big O notation upper bound, pag-scale ng ating input. So, actually have more exercises here. Sana hindi kayo masyadong bulat. So yung first one, parang yung nasa handout lang din naman. So yung pag-add sa sum is just O of 1. And then yung ating iterations ng ating loop is equal to x. So x times O of 1 is O of x. And then yung overall, yung function, is O of 1 plus O of x is O of 1. So O of x function 1. Tapos si function 2, ayun, dito sa loob, constant, yung ating iterations, constant din. So actually, may constant to. So ito yung isa sa mga caveats ng paggamit ng big O notation. So for example, si x natin is just 10. Yung actual na running time nito is 10 times something in the order of 10 times 100. Pero dito sa function 1, in the order of 10 lang. Pero siya yung merong mas pangit na big O or mas pangit na time complexity kasi nagsiscale yung input natin. So, yung big O notation natin only works for x that is significantly large. So, if yung input natin is nasa lower range lang, hindi siya usually, hindi siya measure ng running time, measure siya ng complexity. And yung complexity is nakikita lang pagka malalaki yung input. So, ayun, moving on. Function 3. So ito, yung summation natin, ang addition, siya si constant running time. So yung addition natin over here, siya yung constant running time. And then, gawin natin yung color. Si function 1. Ayun. So the time it takes to evaluate function 1, kailangan din natin siyang i-account dito. So, ayun, nag-add tayo ng dalawang complexities, ng dalawang algorithms. Si function 1, alam natin siya na O of X. So, yung final na time complexity ng line na to is O of X. And then, if we have an O of X na operation, na ulitin natin X times, we have an X cube na time complexity. Tapos, ayun, yung sum at saka yung return, constant lang. So, overall, si function 3 ay O of X squared. So, hindi kailangan ng nested na for loop para magkaroon ng quadratic na time complexity. So, ayun. So, kung yung for loop mo, meron ka pang function sa loob niya, may hindi constant yung time, lalaki siya ng lalaki eventually. So, ayun, X cube to, pero we can actually think of another way to implement this na mas mabilis. So, for example, gawa ko ng additional na variable t, and dun ko lalagay si function call, since pare-pareho lang naman yung naman, papalitan ko to ng t. So, makakakuha tayo ng same result, pero yung dito sa loob, babalik siya to O of 1, O of 1, and magiging linear lang yung loop na to. And then yung line din na to, magiging O of X. So, imbis na magkaroon ng X per term, meron tayong dalawang O of X na terms. And yung overall na time complexity natin is O of X lang. So, doon pumapasok yung analysis natin. So, dahil nakita natin, so meron tayong nakikitang command or algorithm dun sa loob na pwede natin ilabas dun sa for loop, and it will improve our time complexity. So, ito yung isa sa mga applications nung ating pwedeng gawin para i-optimize based on our analysis. So, ayun. In the second example, medyo mas mahirap siyang gawin kasi I yung nasa loob. So, hindi natin siya pwedeng ilabas. So, kailangan niyang i-retain dyan. So, nag-iiba yung running time nung nasa loob mo for loop, depende dun sa input niya. So, we can't resort to the usual multiplication lang. So, kailangan natin actually i-sum up yung per iteration. So, for the first iteration, we have f1 of 0, and then we have f1 of 1 dun sa next iteration, hanggang, so, i-declare ko na lang kasi hindi kasi yung xn. So, f1 ng n-2 and f1 ng n-1. Excuse me. You can argue na lahat to, ito magsisimplify to O of n. Ito magsisimplify to O of n. And then ito, since 1 lang siya, magsisimplify siya to O of 1. Ito magsisimplify siya to O of 1. So, ano makukuha natin? Maraming O of n na terms. Technically, di ba, pag in-add natin sila, pag O of n plus O of n, di ba, O of n lang din. But, hindi naman natin alam kung ilang O of n yung idadagdag natin. So, yung n-3, dadagdag pa ba natin siya? Yung n-4, dadagdag pa ba natin siya? So, kailan tayo titigil? So, medyo, I guess, isa siyang pitfall ng big O notation, yung pag-simplify ka agad. So, balik natin sa kanina. Ang makikita natin dito, wag muna natin i-apply yung simplification ng big O. Instead, kunin natin yung time, which is maging n-1 lang talaga siya, n-2. So, wag muna natin tanggalin yung mga constant na terms. Ang nangyayari dito, summation siya ng from 0 to 1, 2, 3, 4, etc. hanggang n-1. So, it's a sum of an arithmetic series. So, yung sum ng arithmetic series natin is yung sum ng first and last. So, dali tayo ng additional na line. So, sum ng first and last n minus 1 plus yung last 0 times yung number of elements. Ang number of elements natin is n minus 1 plus 1 kasi 0 tayo nagsimula. So we have n over 2. So n minus 1 times n over 2. And yun yung, tsaka pa lang natin siya isi-simplify. So when we have this one, so we have, so ano lang naman siya, di ba? Multiplication siya ng n over 2 times n over 2 times 1. So n over 2 times n squared. And then, I guess, nag-iba ako ng variable x. Pero wala naman nagbago sa discussion. Pareho lang ay x. So x squared minus, so meron tayong over 2. So ano yung sabi natin sa coefficient? Hindi siya masyadong nagma-matter for us. So yung over 2 pwede natin tanggalin. And then, ayun. So meron tayong x squared over 2 at saka minus x over 2 naman. So minus x. So mawawala lang din yung x. So eventually x squared lang din to. So actually, this is a very usual na scenario wherein yung running time natin dito sa loob is linear with respect dun sa ating variable na ina-iterate. So actually, maganda ng tandaan kung madalas lumitaw yung ganitong basically ganitong pattern. So yung magsa-start siya na O of 0 plus O of 1 plus O of 2, O of 3 hanggang O of n. Pwede mo na siya agad i-simplify to O of x squared. So ayun. Then si function for overall ay O of x squared. Nasundan? Yun. So doon tayo medyo nag-iba, no? Kasi nagva-vary yung complexity nandito sa loob. Okay. Okay. Next sa function 5. So for function 5, we have a rather simple na loop, pero yung nasa loob ng range function ay function 3. So this is the same as having it this way, na mag-assign ng temporary variable kay dun sa result ni function 3 and yun yung gagamitin sa range. So may assumption pala tayo dito, no? So yung range of x, yung operation na to, we assume this to be O of 1. Kasi in this example, ay nga, ito is big O ni function 3 evaluated at x. Na pag binalikan natin si function 3 ay of x. So this is O of x. Then ito, meron tayong O of 1 times t. So t times O of 1 is O of t. Pero saan equal si t? T is equal to yung actual na value ni function 3. So hindi siya equal kay x. Saan siya equal? So kailangan natin tignan si function 3. Ano yung magiging sagot niya? So si function 3, ang ginagawa niya is ina-add niya kay sum yung sagot ni function 1. X times. So si function 1, kailangan pa natin balikan. Tanggalin ko muna yung annotations. Tanggalin mo. So si function 1, ang ginagawa niya, ina-add niya si x sa sum, x times. So that is equal to So yung sum dito equal siya kay x added to itself x times, which is the same as x times x, di ba? So x squared. So yung function 1 of x equal siya kay x squared. So this is not to be confused with pag ginamit natin to, big O ni function 1, ibang usapan siya. X squared yung sagot, pero O of x yung time complexity. So nagkataon lang kasi na yung sum natin related din siya sa value ni x. So if we know na si function 1 is equal to x squared, pagdating natin kay function 3, alam natin sa line na to, function 1 is equal to x squared, and si x squared, in-add natin kay sum x times. So yung sum natin dito will be yung x squared, or I guess t, times x, which is equal to x squared na eventually x cubed. Now, since si function 3, ang sagot sa kanya is x cubed, t is equal to x cubed. So, this one becomes O of x cubed. So, saan nanggaling yung x cubed? Isang loop lang naman to. Ayun, yung value kasi ni function 3, x squared. Tapos, ang value ni function 3 ay x cubed. Now, yung pagkuha ng function 3 itself is O of x, di ba? So, ito yung temporary variable. So, pwede natin siyang i-replace dyan. Para ilagay ko dito, yung running time ni function 3 of x ay O of x. So, yung total na running time, or time complexity rather, is O of 1 plus O of x plus O of x cubed plus O of 1, which is x cubed. So if it happens na kunwari si function 3, x to the 4th pala siya, yung running time niya, edi siya yung magiging dominant na term. So kahit na x cube yung loop natin, yung pag-generate nung pag-evaluate ng function, siya yung nagko-cause ng biggest na delay. Okay. So, ayun. So, essentially dito, ginamit natin yung value ni function 3. And dito, ginamit natin yung actual na time complexity ni function 3. So, magkaiba sila. So, dito x cube siya, dito O of x lang siya. Well, dahil pinalitan natin, di ba? In-optimize natin siya. So, imagine if kanina x squared pa to, di ba? So, magiging may x squared to. Hindi naman natin yung sagot. Anyway. Okay. So, ito yung naka-for loop siya. What if itong naka-while loop naman siya? So, similar lang sila. So, sum equals 0, I equals 0, I less than function 3. Sum and I nag-increment. So, si I nag-increment by 1. So, si while loop natin, uulit siya the number of times kung ano naman yung value ni function 3. So, na-identify naman natin si function 3 siya ay x cubed. So, effectively, x cubed to. Pero, ano yung multiply natin sa kanya? Is it just O of 1? So, not really, because recall, ang ating conditionals, so si while loop is considered a conditional din. Kasi every time na mag-execute yung loop, kailangan mong i-check yung condition kung true pa rin. And every time we check mo yung condition, kinocall natin si function 3. So, in addition doon sa O of 1 dito sa loob, meron tayong big O ni function 3 doon sa ine-execute natin. So, ang difference nila dito, ito, si function 3, once lang siya mako-call para ma-generate yung range. Kasi yung for loop is, wala naman siyang condition na chine-check. Dinadaanan niya lang lahat ng elements ng list na to. But for this one, si function 3, similar doon sa naka-if statement siya, every time na daanan natin siya, whether it becomes true or false, kung ano man yung value niya, dinadaanan pa rin natin. So, pumapatong pa rin yung running time niya. So, recall yung big O ni function 3 is just x. Tama. Big O ni function 3 is just x. So, this results in x to the 4. So, ayun. Function 5, function 6, pareho sila ng ginagawa. Ayun, nagsa-sum plus equals 1 lang siya. But, mas malaki yung running time ni function 6 kasi nasa loob ng conditional or essentially, napunta sa loob ng loop yung pag-check ni function 3. So, isipin nyo, this is the same as naka-while true ka dito. And then, meron kang if statement dito sa dulo. If not magbe-break. So in this case, every time na mag-run yung loop is na-execute yung function, nakakain yung O of x na time. So, ayun. Hopefully that makes sense. So, ayun. So notation now, we usually put yung big O kasi yun nga, mayroong mga coefficients, mayroong mga constants na tinatanggal natin dahil naka-big O notation. Yun. Okay. If walang questions doon, we have a few more. Kaya niyo pa ba? Medyo 2:30 na. Kaya pa? Meron pa tayong 4, I guess. Dito sa function 7, so si I dito nagpa-plus 1 lang, dito nagpa-times 2 siya. So, imagine, sa first run, you can tabulate it. So, I tapos run. So, initial run 0, si I natin is 1. So, second run, or the first actual, after nyo madaanan to once, we get I equals 2. And then, we get I equals 4. We get I equals, hindi pala 5. We get I equals 8. Pagdating sa run number 4, we have 16. And then, pag 5, 32. So, napapansin sa I, nagdo-double siya every time. So, ibig sabihin lang nito, if our x is, for example, 4, ilang beses tayo magro-run? 2 times. Pag si x, I guess, pag x equals 4, runs equals 2. Pag x equals 32, yung runs natin equals 5. So, nakikita ba yung ating pattern? So, yes, no, maybe. So, yung number of runs natin, so for example, gusto natin ng 10 runs. Ano dapat yung x ko? So, x should be 2 to the 10 or 1024. para 10 times tayo mag times 2 bago mag-terminate yung while loop. So, given x, ilang runs tayo? So, essentially, x equals 2 to the number of runs. So, pag i-isolate natin yung runs, it's mahirap magsulat. So, pwede man lagay ko na lang log edge. So, ay log base 2 of log base 2 of x. Saan nakuha yun? So, binaba, since nasa exponent si runs, logarithm both sides. So, ayun, ang number of runs natin is log 2 of x. So, log 2 of x times of 1, we have a total of big O of log 2 of. So, ayan. So, saan natin nakuha yung log? Tinry natin, well, hindi naman natin, nag-succeed naman tayo, so hindi lang natin tinry. Nakuha natin yung number of iterations ng loop natin as log base 2 of x. So, doon tayo nagkakaroon ng mga logarithmic na complexity. So, yun. So, what if gawin ko itong 3? Ano mangyayari dito? Magiging log base 3 of x lang. However, di ba, ano kasi yung property na yun? Log base a of b is equal to log b over log a. Tama? So, kahit anong base to, di ba? And this one, si a, is a constant. So, essentially, we can write any log na gusto natin na base. So, I can actually use base e or gamitin ko yung ln, natural logarithm, para makatipid sa letters. So, pwede kong gawing ln x kahit na log base 2 of x siya. So, and actually, kahit gawin ko tong times equals 10, technically log of x na base 10, pero I can put ln x kasi, ayun nga, constant multiplier lang naman para i-convert siya. Although, actually, based nga pala sa ating mga usual or yung mga standard na forms natin, we actually use log of n na walang base. So, kahit log of 2 siya, we still use log of n. Then we have function 8. So, ayun, so medyo combination na siya. We have yung calculation ng function 7, which is of ln x. Then recall function 3 of x. Yung number of iterations natin, yung running time natin sa loob is of ln x, and then yung ating conditional, big O ni function 3 of function 3 of x. So, and note na ito is yung number of iterations or runs. Kanina kasi letter I yung gamit ko. So, baka malito kayo. And this one is yung actual na time complexity. Yes. So yung function tree natin, recall it was x cubed times O of ln x plus O of x. So at this point, pwede natin tanggalin si ln x kasi mas malaki si O of x sa kanya. So overall, yung ating loop ay O to the x to the 4. So si function 8, pareho siya ng time ni function 6. So di porket meron tayong function sa loob, dito constant lang siya, is magkaka-effect siya agad sa ating running time. So ayun, this could be something useful. Kunwari, naghahanap kayo ng functions na i-optimize nyo. And ito, nakita nyo, si function 3, yung running time niya yung mas nagmamatter over sa running time ni function 7. So si function 7, since mabilis lang naman siya, ln x lang siya, hindi mo na siya kailangan i-optimize. So in this case, si function 3 naman yung kailangan natin i-optimize. So hanapan natin siya ng mas mabilis na way. Actually, yung number of iterations pala yung problem, hindi naman yung running time talaga. Well, anyway, if na-improve mo si function 3, mag-i-improve si function 8. Pero pag in-improve mo si function 7, hindi talaga mag-improve si function 8. So, something to notice din. Then ito, nested loops lang din. So, this is O of 1. And then, this one naman is x times O of 1, which is O of x. Then this next line is x times O of x, which is O of x squared. So in general, pag nag-nest, nag-multiply lang. Yeah, O of x cubed, which is yung total natin for this one. Okay, so for function 10 naman, yung difference naman dito, yung range natin is hanggang yung previous na iterator or yung previous na counter natin. So in this case, yung inner for loop natin, medyo familiar siya, di ba? So for loop na sa range ni I, and then sa range naman, dito naman is linear with respect to J. So nakuha naman natin kanina na pag meron tayong linear dito sa loob, recall yung, siguro kung tanggalin mo natin to. Similar dun sa kanina natin nakuha dito. So meron tayong linear with respect dun sa counter, and then yung counter is up to a certain number. And yung number na yun, squared, yun yung makukuha natin eventually na total sa kanya. So same with here. Itong 4K na loop natin is linear with respect to J. So makukuha nating time dito without any additional na computation. It's actually just I squared. Through a similar na analysis, ito, yung big O niya is magiging I squared. Well, yung longer form niya would be, syempre magsa-start si I at 0, so 0 squared plus 1 squared plus 2 squared and so on and so forth hanggang x minus 1 squared. And through a similar, in a similar way, nasa-simplify natin to just be of x times x squared. And makuha natin na yung total x cubed siya. So basically, yung result ng summation yung nasa loob. So, pero yan, usually din kino-consider kung linear naman yung relationship ng loop is kung ano yung maximum ng mga variables, yun na yung kino-consider. So ano yung maximum variable ni J? It's I. Ang maximum value ni I is X. So, ang maximum value ni J is X. Maximum value nito is X. And X din to. So, as long as na linear yung relationship, eventually, mauuwi ka din sa X cube. And then, ayun, similarly dun sa analysis kanina, sure tayo na mas madaming times mag-execute ito kaysa dito. Pero yung complexity nila is pareho pa rin. Kasi yun yan, we're dealing with large number or large values for X. And ayun. Next one naman is, ayun, meron ng dalawang for loop na magkasunod. So si function 2, if you can recall, this is big O na constant. So this loop is x times of 1 or of x function 3 it's of x, if you can recall. So this one is x times of x, which is big O of x squared. So yung for loop na to, yung dalawa na to, is ka-level niya itong function 1, which is, we recall, O of 1, right, of x. So unang-una, O of x. So for this one, O of x, and then we have another O of x and another O of x squared. So since yung tatlong algorithms in sequence, kukunin lang natin or kailangan lang natin consider yung pinakamalaki for this one. So x times big O now x. And then x squared pa lang pala. X cubed. And yeah. And for the last one, ayan, so medyo naka-rearrange. So ayan, I like to start with the innermost, the loop, which is big O of x. And then we have a loop over here, doon sa kanya, na x times. Then ka-level niya yung ka-level niya si O of function 2, which is constant lang. So magka-level to and ito, mas malaki to. So we don't really need to consider this anymore. So so when we go back to this loop, pagka yan na natin siya, you can simplify na ito na lang yung consider. So x times big O of x squared, which is big O of x cubed. And then we have another function here na same level. So magkasunod sila mangyayari. We get big O ni function 3 of x. which big of x din. Linear lang. So, in this case, mas malaki pa rin to kaysa dito. So, kahit di natin siya consider. And then, dito is big O x to the 3 multiplied by x sa labas. So, x yung number of iterations, and then x cube yung running time nung nasa loob nung for loop. So, we have x to the 4. Then, lastly, meron pa isa dito. Big O ni function 11, which is of x cubed. And since mas malaki pa rin si x to the 4th dito sa loob, ayun, hindi natin siya sama, and we have overall big O na x to the 4. So similarly, what if si function 11 pala x to the 5? So parang hindi nagmatter yung for loop natin. Kahit napabilisin ko si function 1, kahit siya yung pinakamadalas gawin, hindi magsi-speed up or hindi mag-i-improve yung time complexity ng ating function. So, ayun. So, I hope that makes it clear why this sort of analysis is important, especially for us na gustong optimize yung ating code. So, any questions after those? Wala naman ba? Okay, so actually, well, ang target ko sana 1 hour lang tayo. So, I guess medyo nag-extend ng konti. For sorting algorithms, meron namang videos. Pero if gusto niyo silang ma-visualize, or actually tignan ko na rin yung makamali yung mapakita. Ibang algorithms yung mapakita ko. So, for example, dito insertion sort, you can go to visualgo.net or visualgo. Visualgo. So meron din siyang parang slides. You can go through them. Pero pwede mo naman i-exit lang. And we have this list over here. And you can select bubble sort, selection sort, insertion sort, etc. And then you can click yung sort dito para makita natin paano siya nagsisort. So ang ginagawa ni insertion sort is kukuha siya ng isang element and ipapasok niya siya to a sorted sub array. So yung nasa left dito, si number 8, part siya nung sorted na sub array. Si 25, siya yung next element na i-add niya kay sorted sub array. And it goes before number 8. So next si 31. Let's just run it a few more. So kung yan, meron na tayong sorted na sub array dito. We have things left to sort. Si number 24 yung next natin i-insert. So hahanapin natin yung tamang pwesto niya, which is before yung 25. So since alam natin sorted, kailangan lang natin siyang i-compare dun sa mga pinakamalalaki dito sa right side. So ayun. So kukuhanin si 19, compare siya kay 32. Mas malaki si 32. So dun siya sa next. Mas malaki si 31, dun siya sa next. So laki siya sa susunod, etc. And etc. So parang kung meron kang deck of cards, nag-i-arrange ka, di ba? Kukunin mo yung, meron ka nang i-arrange sa simula, may ma-arrange ka. Tapos kukuha ka ng isang card, hahanapin mo kung saan mo siya isusok-sok. Tapos kukuha ka ng next card, hahanapin siya sa papasok. So, kaya siya insertion sort. So, pwede mong i-play pa yung and merong pseudocode dito. So, medyo generic siya. And hindi siya specific to any programming language. So ito si insertion sort. Kuha ng isang item, hahanapin kung saan siya i-in. So, kaya siya insertion sort. Yung other ways of sorting, what is bubble sort, is magko-compare siya nung dalawang magkatabi, kung sino mas malaki, lalagay niya sa kanan. So, ayan, compare 15 and 30, mas malaki si 30, siya yung magsistay sa kanan. Then, get yung next two elements. So, mas malaki si 34, 34 stays on the right. Next two elements, 34 and 24. So, mas malaki si 34, so mag-swap sila. And then, yung next na i-compare is si 34 and 12. So, mas malaki si 34. So, swap sila. The next is co-compare ulit. And you'll notice here na parang kung alin yung pinakamalaking element na bubble siya or parang nagfo-float siya pataas kasi consistently siyang magsistay doon sa right. So, ayun. Basically, repeat lang yung operation hanggang hindi na nagsaswap yung ating list. So, yun yung ating bubble sort. So, makikita mo dito, meron tayong sub-sorted or sub-array na sorted na lumalaki by 1 after each iteration. So, at the worst case, n times mo siya uulitin and kada ulit mo is gumagawa ka ng swaps. And yung swaps mo is magsa-start siya from n hanggang n swaps to n minus 1 to n minus 2 to n minus 3 hanggang 0 hanggang 1 swaps. So, yung worst case ni bubble sort is n squared. So actually, pwede nyo yung i-deduce sa ating mahirap siya sa bubble sort kasi do while siya. Sa insertion, kung meron ka pseudocode, actually, pwede mo lang i-analyze. So, mag-e-extract ka tapos i-shoot mo siya. So, ilang beses ka mag-e-extract? N times. And then, yung pag-shoot mo, hindi naman siya instant. So, kailangan natin mag-compare. So, at the worst case, you make n comparisons. Kung wala pagdating natin kay 5, at the worst case, you need to make n comparisons. And at the worst case, kailangan mo siyang gawin n times. So, n squared yung ating time complexity. I think mas explained naman yun dito sa handout natin. Sa ayan, merong mga summation. Eventually, makukuha nyo rin yung n squared siya. Yung selection sort naman is isa-select mo yung minimum element. Hahanapin mo siya, lalagay mo sa umpisa. Then, nahanapin mo yung next na minimum element, lalagay mo siya dun sa umpisa. And then so on and so forth. So, ang ginagawa mo, naghahanap ka ng maximum or minimum number doon sa isang list. And it takes n times, so, kasi dadaanan mo lahat eh. So, n comparisons yun to get the minimum. And you need to do it n times to get n elements na nakasort. So, ang ating selection sort ay O of n squared. So actually, itong tatlong to, yung tinatawag na O of n squared na sorting algorithms kasi n squared yung complexity nila. Then we have this merge sort, quick sort. Sila yung ating mga mas mabilis mag-sort. But ito, recursive siya na function, which analysis niya is hindi siya as straightforward nung ginawa natin kanina. But yun, ma-encounter nyo naman siya in the following weeks. So si merge sort is gagawa siya ng mga sorted na list tapos i-merge niya sila. So mas madali kasi mag-merge, mas madaling mag-sort ng dalawang list kung yung dalawang list mo is sorted. Okay, so I guess we can start with questions. So what is an example of an algorithm with an n factorial na complexity? So this usually involves combinatorics. Tama ba? Basta yung may combination. So for example, find when an algorithm wants to find the lahat ng poker hands, if naglaro kayong poker, find the probability na mananalo ka after 5 cards, for example. So yun yung may possibility na umabot ng n factorial kasi there are 50, well, I guess yung for the first card meron 50 possibilities, second card merong 49 possibilities, yung third card merong 48 possibilities. So ilang scenarios yon? So that's 50 times 49 times 48, etc., etc. So nagmumukha siyang factorial na expression. Although madami naman ng optimizations yon. So yun lang yung straightforward na approach. So yun yung example ng algorithm na magkakaroon ng factorial na time complexity. Although usually, sila yung mga algorithms na hindi pa optimized kasi pangit ang n factorial. So people don't leave it at that. They improve it naman. And merong mga algorithms na yung straightforward na solution might be factorial, but there would exist na solution na hindi. So, ayun. So parang in practice, madalang ka lang makakakita na ginagamit talaga na n factorial yung complexity kasi, well, ayaw siya gamitin na. Kung nakagawa ka ng algorithm na n factorial yung complexity, probably kailangan mo maghanap ng optimization for it. And hindi siya maging n factorial. Okay. So I guess can that answer your question? I think it does. Yeah, so yung mga sorting algorithms natin ito, puro mga n squared, yung presented dito. Yung mga, kasi may kita natin yung merge sort, siguro spoiler alert, n log n, log linear yung kanyang sorting, I mean yung kanyang complexity, but it does come at a cost. So for example, si insertion sort is, kung i-notice niyo yung meron tayong space sa baba, so parang representative yan ng scratch work natin. So yung scratch work ni selection sort, konti lang yung nilalagay niya sa baba. Pero kung titignan niyo si merge sort, ang dami niyang nilalagay dito sa baba. So madami siyang scratch work na ginagawa or parang madami siyang memory na ginagamit. So in order to get a faster algorithm, usually we use memory. So yeah, those are topics for yung future na weeks, no? But ayan, for now, we have time complexity analysis, gaano kabilis na run yung ating algorithm. So, are there any more questions? I guess wala naman na. For the assessments for the week, you have one assessment quiz sa UVLE. So, ito siya, yung assessment quiz dito. And you also have a formative assessment na pwede nyo sagutin. Well, actually, essay siya. So, pwede ko siyang pakita kasi wala lang siyang grade. So, ayan. So, what does big O mean to you? Try to compare it with something else. So, ayun, depending on your answer, you can give feedback naman. Tapos, kung tama yung pagkakaintindi nyo, makakonfirm nyo doon. Kumbaga. And then, we have an assessment quiz. Hindi ko siya pwedeng i-preview kasi, ayan. So, meron siya for now limits dun sa attempts. Pero if you need more than 6 attempts, or actually 3 attempts siya kami. Hindi ko naman yung 6. Pero yun nga, we do allow unlimited attempts dun sa ating graded na quiz if kailangan nyo pa ng more than 6. Wag naman sana. uh, just send me an email. So, parang ano lang, parang sulitin nyo naman yung kada attempt. So, alam ko multiple choice yung quiz eh. So, uh, try to finish it in the least attempts possible. For example, if kung naghuhula na lang kayo, I would much rather have you ask me for some advice rather than maghula kayo ng sagot. Kasi kung nahulaan nyo nga yung sagot, okay, natama kayo, pero hindi nyo alam bakit siya tama. So, mas important naman na alam nyo kung bakit yun yung tamang sagot. And then lastly, we have parang worksheet problem set type of exercise. So meron tayong, ay hindi pa pala yun. Hindi pa pala to. Coding exercise pala yun. This one, big O problem. So para siya yung ginawa natin kanina. We have example problems here and kinuha natin yung time complexity. So ganun din naman siya. Merong mga code snippets dito. Hanapin yung time complexity. So you can download this and annotate it. Or pwede kayong mag-start with a completely blank sheet of paper and then i-reference. Make sure na lang na nire-reference niyo tamang function when you do your solutions. So actually, ang preferred ko naman is pwede nyo naman i-annotate to if meron kayong PDF viewer. Usually, meron naman silang options for that. So, data mo naman ganyan. What if per line, sabihin mo, this is O of 1, this is O of 1 then, etc., etc. And then, and eventually, i-box nyo na lang yung final answer nyo para malinaw. Like this. So, wala namang required na format. Ang mag-check nito is most likely me or ang ating SA, si Brian. Pero yun. So kung ano yung yun. Yeah. Annotate ko na lang. Yung problem 7 is a more formal question. If you have trouble understanding what this is looking for, just send me an email. It's pag sinundan nyo naman yung handouts, malalaman nyo naman kung ano yung hindi doon. So, then, ayun, number 4, big O coding exercise. Merong binigay na coding exercise. Submit a code snippet for a function that accepts a list of size n and prints all integer from 1 to 10. So yung complexity ng function should be O of n squared. So effectively, ang pag-print ng 1 to n, linear lang dapat yun. But you have to find a way to make your code be O of n squared. So medyo counterintuitive siya. Gusto mong bumagal yung code mo. But I guess pag nagawa niyo yun, may at least naiintindihan niyo yung ibig sabihin ng complexity. So, hindi siya nakalagay as hacker exercise since yung functionality is trivial. So, para yung input is a size of list 4, the output is 1, 2, 3, 4. So basically, upload nyo lang yung code nyo and we will check. Then make sure and highlight ko na lang din point distribution. I think this is 40 points yung quiz, 40 points yung parang worksheet, and 20 points yung big O coding exercises, and you need 50% lang pala for a week, so you can just do kayo, pwedeng itong unang dalawa lang, yung big O code, kahit hindi gawin, may 80% na kayo. Or pwede nyo gawin yung isa dito sa dalawang. So, of course, ang suggestion naman, gawin lahat. Pero if wala na kayong time, make sure you focus on the right assessments. So, ayan. Meron pa bang questions? Anything else? So, ayun, sabi ko 1 hour lang, pero medyo nag-extend tayo. That's alright. So, thank you very much for attending our session for today. If there are no more questions, we may leave the meeting. There are no more questions, i-end ko na lang yun. Bye-bye. See you next time.